Objective 4, find graph features algebraically of a quadratic function from vertex form. So we've been working solely with standard form quadratic functions, and now we're going to look at what vertex form looks like and how vertex form automatically gives you the vertex, and so it'll help you to graph a rough sketch of a function and then label some key features as well. Now from vertex form, all I really care about is whether or not you know if it opens up or down, does it have a max and min, can you find the vertex, and then from the vertex can you find the axis of symmetry. The y-intercept and x-intercepts aren't as straightforward from vertex form, but once we learn how to draw these perfectly, which will come in the next topic, then you should be able to find the y-intercept and x-intercepts as well, no matter what form you have, whether you're given standard form or vertex form. So let's begin and look at the same example we've been working with. This is the standard form equation, y equals 2x squared minus 4x minus 3. I know it's standard form because it's in the format ax squared minus or plus bx minus or plus c. So it has the a, b, and c. Now, there's a few differences, I suppose, between standard and vertex. The main similarity is that, if you notice, it has an a up here, and the vertex form is given to you as y equals a times x minus h squared plus k. So the a and the a are always the same, all right? The beautiful thing about the vertex form, like I said, and that's why it's called vertex form, is the vertex is given to you. All right, the vertex will always be h, comma, k. I'm going to put in parentheses that h is the x value, k is the y value. Just think left values are x values, right values are y values. Input, output. Now, the main thing you need to know from vertex form, there's one piece that might trip some people up. If you notice, this is the quadratic term, the power of 2. The power separates the x value and the y value. Notice the left value is the h value or the x value. The right value is the y value. So that automatically drops down and becomes your vertex. But one thing to notice is the h value is line to you. All right? I've said this, and I've said this before, that song, to the left, everything you own in a box to the left. That Beyonce song, she's dating Jay-Z. He might have cheated on her, which means he might have lied to her. So if everything you own in a box to the left is lying to you, there's the bell. So the h value to the left of the power is always lying to you. If you notice, in the function y equals a times x minus h squared plus k, it's x minus h. But if you bring from the function to the vertex form, it's a positive h. So it's lying to you, or it's opposite of whatever it is. If you move it from vertex to function, then you have to switch the form. If you move it from function to vertex, you have to switch the sign. So just keep that in mind. The h value is lying to you. K value is telling the truth. All right? The x value is lying to you. Y value is telling the truth. Let's look at an example then. All right? So ideally, at the end of this video, during your practice, you're going to be given vertex form of a function. In this case, y equals 2 times x minus 1 squared plus 5. I lied, it's not a plus 5, it's a minus 5. Y equals 2 times x minus 1 squared minus 5 is vertex form. This format of vertex form is the same function as standard form 2x squared minus 4x minus 3. I just brought it from standard form into vertex form. And so in this objective, you're going to be given functions that are in vertex form, and your goal is to be able to find the vertex, describe to me, does it go up or down, does it have a max or min, and based off the vertex, what is the axis of symmetry. And then from vertex form, in the next topic, we're going to talk about graph transformations as well. And so the whole goal of this whole entire module is, can I find the vertex? In standard form, the whole main thing was finding the vertex and basing information off of that. In vertex form, it's no different. All right, transformations will come based off the vertex and the parent function y equals x squared. So just keep that in mind. All right. Now, if you notice, I can find the vertex here for standard form. X equals opposite b over 2a, 2 times 2. We've done this before. 4 divided by 4 is 1. So the x value is 1, the y value is 2, 1 squared minus 4 times 1 minus 3 equals negative 5. So the vertex is 1 comma negative 5. I know that from standard form. I know the vertex is 1 comma negative 5, which means the axis of symmetry is 1. And both of these functions, if you notice the a term in both of them, are positive. So if it's positive, it opens up, and that has a minimum. All right? That's all I really care about that you can do in this process. Now, one thing, though, from vertex form, because this is how it's going to look on your practice work, you need to be able to recognize, and if I see this 2x minus 1 squared minus 5, I need to identify the h value and the k value. All right, because that becomes my vertex. The vertex then is the h and k value. But remember, the h value to the left of the power, to the left, everything you own in the box to the left is lying to you. So if you notice, it's x minus 1 in the function, but it has to become plus 1 in your vertex. And it becomes 1 comma negative 5. All right, and if you notice, it's the same thing. We found it mathematically from standard form, 1 comma negative 5, and it's given to us in vertex form, and that is the beauty of vertex form. But you just have to remember that the h term is always lying to you. Now, there will be a challenge type problem where you will have to, if given a standard function, can you put it in vertex form? So if I write this function out, y equals, and I want to put it into, it's given to you up here, but y equals, my a term doesn't change, so 2, parenthesis x. Now this is where I have to see that the h term in vertex form, this is the h, this is the k, for x and y, the h term is lying to you. So if you notice, it's positive 1 in the actual coordinate point of the vertex, so it's lying to me in the function, so it's x minus 1 squared, and then the k term is always telling the truth, minus 5. So these are two expectations of this objective. If given vertex form, can you just tell me the vertex, knowing that the h term is always lying to you? And if given the vertex of a function, can you write it in vertex form? It's pretty straightforward. You just have to know that if it's positive in the coordinate point of the vertex, it's going to be negative in the actual function and vice versa for the h term. All right. So at this point, I want you to I just edited this a little bit within the video. So you don't have this on your paper, the vertex form y equals negative x minus 3 squared plus 7. But I want to give that to you. This is the same thing. This standard form right here and vertex form right here. Same function, just written in different forms. All right. So I want to see if you can do the same thing I just did in the video. Can you find the vertex from vertex form? And then can you find the vertex from standard form over here and compare the two, make sure they're the same. And then after you find the vertex in standard form, can you rewrite the function to make it look like this? And I know I'm giving you the answers, but I want you to be able to recognize how to write the function if given a vertex in vertex form, knowing that the h term is lying to you. So go ahead and pause that and try that process. At this point, you should pause the video and just practice this a little bit. On the left in standard form, I found the vertex. And again, you found this vertex before, so that should be pretty easily reviewed. But the vertex is 3, 7. I found my x value with the formula, and then I inputted my x value back into the y value to find the y value, or y equals to find the y value of the vertex. Now, these are the key pieces of this video that I care about. Can you, if given a vertex, 3, 7, can you write it in vertex form? Knowing that it was negative, so that negative stays there. And then y equals negative x. It has to be, if it's a positive h value for your vertex, then it has to be x minus 3 in the function. If it's a negative value in the vertex, then it has to be x plus 3. It's opposite. It's lying to you. So x minus 3 squared, and then the k value or the y value is always telling the truth. And then if you're given vertex form over here, can you identify the vertex based off of the function itself? And if you notice, it was x minus 3 in the function, so it's lying to you, it has to become plus, and vice versa. Now you are ready for the practice. On these pieces, All I really care about is, can you find the vertex? And based off that, the axis of symmetry. Can you state that the parabola will open up or down or has a max and min? And then sketching the graph of each function will help you find the domain and range. Now, Desmos, I can show you that. It's a really cool online website that lets you graph these functions and look at the graph and different graph features as well. But 1 through 5 is the main